Okay, let's have a look at question 33. Liquids X and Y do not react with one another. They have identical boiling points. When a particular volume of X is shaken with a similar volume of Y, they form a liquid mixture Z. The average intermolecular forces in liquid Z are stronger than the average of the forces in X and in Y. Which deductions are correct? Okay, so let's think about this question. What is it really about? Well, this is about intermolecular forces, and it's about an understanding of an exothermic or endothermic process, okay? This is not a reaction. We can see that because it's just saying they're talking about these things mixing. But it is a process, and processes can be exothermic or endothermic, okay? And the really key information here is that liquid Z, or the intermolecular forces in liquid Z, are stronger than the forces in X and in Y. So this is really, really important, okay? Because what does that really mean? Well, if you have stronger bonds, then effectively what that means is that that's going to be more stable. In other words, it's holding less energy. So if we're going to draw a reaction profile, if our mixture, which we can think of here kind of as our products, as we remember doing energy profiles for reactions, I'll just put a line in here, okay? So our product Z is more stable here than our X and Y, which are going into our mixture. Now, this isn't a reaction, so don't get confused here, but what I'm saying is that the energy, or the average energy in X and Y that go in before forming this mixture, is greater than the average energy of the mixture coming out. And you know this because it's told you that the intermolecular forces are stronger, and therefore liquid Z is more stable. So yes, as we know, the difference in the energy is then released to the atmosphere. So this will be exothermic. So number one is correct there. Okay, number two says the vapor pressure of liquid Z will be less than that of either liquid X and liquid Y. Well, we can kind of use this graph still, but we need to know what vapor pressure means. So vapor pressure can be thought of as the tendency to become a gas, okay? Tendency to become a gas. So again, X and Y, which have basically got more energy in their bonds there, they are more likely, they're more unstable. Think of it in terms of stability, okay? They're more unstable, and therefore they're more volatile, more tendency to become a gas, whereas Z has a less tendency to become a gas because the bonds of the intermolecular forces are more strong, therefore it is more stable. So 2 is correct as well. And then the third point here is the boiling point of liquid Z will be lower than that of either liquid X or liquid Y at the same pressure. Now this doesn't make sense, because if it's going to take more energy to push away these stronger intermolecular forces, then that would result in a higher boiling point. So the boiling point would be higher for Z compared to X and Y. So this would be incorrect. So 1 and 2 are correct, which means that our correct selection here is B. Hope that's helped.